Hi, my name is Łukasz Langa.
And my name is Pablo Galindo.
And this is the Core.py podcast, an established podcast where we discuss internals of CPYTHON and our adventures in making a new version of your favorite programming language.
But we were missing in action after the last episode, Łukasz. What happened, Łukasz? What happened?
Well,
why no episode? We lie again.
Yes, every 2 weeks. We've been to PyCon US, and that was intense. Both of us were wearing multiple community hats, and there's been a lot of things happening, like the entire event.
Bunny ears in my keynote.
Yes, you even had like a literal bunny hat like on stage.
Blame.
Yes, and that wasn't even the only outfit you wore. So yes, there was a lot that happened.
No, ominous.
Right. So in this Sorry for Being Silent for a Month episode, we're going to go through the things that happened in Pittsburgh and after.
All right, let's start with the Language Summit, which happens before the conference. Wow.
That's the thing. Yeah, we start on the Wednesday before the conference. Well, it is, in fact, like part of the conference already because you might already have a tutorial on this day. But if you don't, and you are a Python contributor, you might go to the Language Summit, which is this sort of invite-only event.
Exclusive, very exclusive.
It is exclusive not
days,
because we like secret handshakes. That's only the secondary reason. The main reason is that like what we need is like a closed space where we can discuss and share problems and hopefully solve them for developing Python implementations. So
have we ever solved any problem there? I don't think so.
I think, kind of imagine if last year at Language Summit, we have not like beat our own drum and said like, hey, we're doing PyRepo, is going to be awesome. And
that was a problem that was kind of solved. We were there to just show our thing, and then people say, what about Windows? And then we say, all right.
Yeah, but like the pushback about Windows was like, okay, higher priority for that.
All right, it's true. We kind of solved it. Well, I mean, we Dino did it.
Dino, yes. Thank you, Dino.
Thank you, Dino.
Yeah, but in any case.
So what happened? What happened at this Language Summit?
Well, there was more people than ever. We actually had to like both tell a few people who wanted to come that they cannot because there's not enough space. But at the same time, it was the largest room we've ever had and the most people we've ever had at the event, which was interesting because we are set up in this way where we have a U-shaped room so that we can discuss and everybody sees their faces when they're talking to other people.
Yeah, but that setup doesn't optimize for size of the room.
Yeah, like at some point you cross the sort of like sweet spot and then you started wasting a ton of space in the room, which is both bad because like you could maybe fit many more people, even though it would be terrible for discussion because they wouldn't be able to see each other, but like you are still wasting space. That's true. But more importantly, everybody is super far from each other now, right? Like because the U shape is sort of around the.
It's like you know that 99.999999999% of the atom is empty space. So that was how the room was felt. Yeah. Not great.
Yes, that's how it felt. Like the event is chaired by Emily and I, and we had to like set up sort of like who comes, who does not, and who gets to speak. So there's somewhat of a controversial role there for us because we get to actually select like,
the censorship. Google slang at the censor.
We actually, you could see that this year. We tried to really maximize the floor for as many people as we could. And like, we even received feedback that we might have overdid it a bit. So, like we're going to see how to evolve the Language Summit for future years. But this year, we essentially have like a few blocks, you could call them, of like discussions where the first one is in the morning and ends with a coffee break at 10:30. Then you have another block that ends with lunch. Then you have another block that ends with the group photo and coffee break. And then you have the final block after which you're done.
This is already boring. It's like I wake up and I have a toast with like what about sassy topics? Talk about the talks. Good shit.
There were talks, yes. Well, we started with talking about how to make changes that are breaking less painful. Like Itamar had, I don't know, war stories from how Meta is actually encountering breaking changes and what we could do like to make them more palatable for us. We had an uncontentious talk about contention with Mark Shannon. And then, yeah.
What do you think about that one?
I
Your silence is very noisy, Łukasz Lanka. All right. I find it interesting. It was an interesting idea, but it was, I mean, it was the kind of thing like, what if? You know the series, like the Marvel series, what if? And it's like, very interesting idea. And I mean, if I recall correctly, he had a prototype, which is more than I had in some of my language summit talks, so like kudos for that. But like, it's also like not something super actionable about this. Well, maybe it is. I think he has also a Discord thread about it.
Right. Like Mark also had like a lightning talk that was even more sort of out there, like at the end of the day. Like the sort of most interesting to me, probably like piece of the language summit happened like in the second sort of group of talks, which was the sort of fearless concurrency. Like first we had like the state of free-threaded Python with Matt Page, like who was both interested in like telling people that like, hey, we actually see adoption, things are actually progressing, we are nearing single-threaded performance of the regular Python, and kind of things are really looking up. So he wanted for the steering council or the other core devs to essentially explicitly say, like, what do they think?
There's a PEP that they want to us to accept soon.
Right.
So we are still finishing that.
Exactly.
But like that was an interesting talk. I like the talk.
Is free threading happening? Right. That was his question, and we're gonna see soon enough, I guess.
Well, I mean, the answer is yes. I mean, we spoiler.
Do you want to have?
We said that in the keynote, no? Like the steering council said, like, oh, it's happening. Details to follow. Blah blah.
That was a very weird part of the sort of steering council address. That like,
why?
It was because it was like, we will not tell you that we're accepting this, but we will also tell you to expect us to accept it. It was like, well,
why is that weird?
Because like,
accepting it is full of fucking numbers, dude. Like, for instance, they say, oh, acceptance of this PEP and go to the next step means that the free-threaded Python is good as long as it's 15% is lower or less.
I see.
Well, I would like to think about that fucking number, because it's probably going to be less than 15, right? Mm-hmm. So in that sense, we cannot just accept it at that time, because we didn't have enough discussion,
right? And
we literally were instructing. When this was brought to us, we said, okay, let's discuss in the language summit, because like that, let's see what other people think, right? Because I don't think this is something that the steering council only should discuss.
Yeah.
So now that has been discussed, but we were not ready for pronouncement. But we wanted to use the opportunity that we were on stage and everybody was listening, and to say, well, like this is we believe in free threading. We think this is the future, so it will happen. But we are not accepting the PEP. I mean, it's not that weird, no?
Okay. All right. Okay. I accept this explanation. Makes sense to me.
By the way, I think we lost the Apple censorship, like explicit episode now. I blow it. Sorry, Apple.
Well, we'll see, because like some episodes they just don't attack us like that, but on other ones we're just tagged like
the one that they listen. All right.
So yes, they don't listen to every episode apparently.
Nice keynote the other day.
Oh, yeah, liquid glass, huh?
Cool. Okay, but there is a lot of talks, and we are going to end having 6 million hours. The question is, what is your favorite talk? What was your favorite talk? Pick one.
Wow, it's weird because I'm chairing the thing.
Yes,
so like,
yes. Now, what about it? What is your favorite? What was your favorite? Reveal it to us, Łukasz.
So I will tell you something weird, right? Because you're gonna be like, what?
I will not answer your question, and I will answer this other shit instead.
I will, but like
right.
The one that I was sort of surprised by how kind of productive it was, and how people were much like interested in discussing, was the challenges of the steering council by Eric Snow, who like raised like a bunch of like ideas for improving the steering council by essentially showing like what are the current
challenges,
suboptimal elements of its functioning. Of course, like not every random idea from the room will be able to be implemented or whatnot, right? Like there were some that like were more brave than others. But this entire sort of like engagement between steering council members and the rest of the room, like that's what I feel like the language summit should be about, right? Like there was actual like discussion. People were interested in making a thing better, and they were listening to each other. It was like
for me, it was eye opening. Also, I mean, we also had the chance to answer from the steering council, and I think it was eye-opening also that several people have opposite wants.
Yes,
you know,
yeah,
in the sense that there is some people that are like, oh, please, you know, like it would be great if the steering council goes into PEP discussions and they say early what they think, and there are people that say no because like, you know, now you do this, it's going to move the discussion in some weird place. And then it turns out that like, even if we say our opinion as people, that's not technically our opinion in the steering council because like, you know, it's different hats.
Yeah.
And like, and then it's like people are, oh, well, but the steering council should delegate, but other people want us to be on all issues and comment. And like, that's insane. So it's kind of like it's kind of impossible. Like this is like after some years in the steering council, like what summarizes the steering council experience is you cannot win. Like that's it. It's just like you are here to not win. And then like you get as close to zero as you can, but like it's always negative. Like in the sense that, you know, like hopefully you have a positive impact in the community. That's not the negative number that I'm referring to. The negative number is your emotions. Like it's just impossible. Like you will make people angry and people will not like you anyway. But you know, you're not here to make friends. You're here to you know, make the community better and like blah 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 blah. So
yeah, profound words, but I agree with you. I have no experience being on the steering council. I was part of the Code of Conduct working group. So again, very similar, where you're trying to like solve a problem that we have, but like in the end, you end up being negative on your emotions.
But I agree with you. This was a very positive talk, and it was good to hear everyone. Like I like it. There were other talks that were like also. I mean, I like most of them, if not all of them. But like there were some that were less actionable or like more woozy. You know, like, look at this cool idea that will never happen. Oh, all right, okay.
That's like, I would say this is more in line what we actually would have normally on the language summit, where we explicitly tell people when they sign up for a topic is like, hey, please just don't do like a status report on like, hey, you know, this is what we've been doing. And then
5 minutes ago, the state of free-threaded Python. That was a good talk.
Dude, like that was like one of the 3 sort of like very similarly worded like you know, entries in the schedule. But like if people present us with such proposals, we just have to choose from what we have. So like, you know,
I understand. I just still find it funny.
Those sorts of things are the least actionable for the crowd.
Right.
Like, you know, they don't usually get like much sort of interaction. So yeah, like we've explicitly asked people not to bring those sorts of proposals, but they still do. So like, what can you do? You are not the king of them.
Right.
In any case, yes, you're right that there were many talks, and we have to actually cover the conference and not just the day before the conference. Right. So let me just say this. Seth Michael Larson was our blogger, and he is preparing a detailed set of blog posts about every topic discussed. So they should be available any day now. Like I've already seen like the sort of drafts that are being edited right now. So just, you know, look at pyfound.blogspot.com, which is the Python Software Foundation blog. And in upcoming days, there should be a series of blog posts about everything that happened at the Language Summit, much better reported than what we did right now.
Right. All right. Let's move up to the actual conference.
Right. So we've had our share of talks at the conference, but before we get to those, maybe let's briefly cover some highlights from the conference.
All right. Yes. What do you want to start? The keynote, maybe?
Yes. So the keynote was a strong start to the conference because Cory Doctorow came in and essentially started like very explicitly sort of laying out like how the current situation of technology is being set up in a way where we cannot win.
Like the steering council.
Yes, it's only negative numbers. Nobody can win.
All right.
Yeah, he gave a nursing app example that was pretty striking. How, like, kind of you can pay less to people who are more desperate, right? And so on and so on. Like, and he just said, like, bosses aren't more evil than before. They just have better tools. And then the entire talk, like, kind of goes through concrete examples. So I think, like, kind of it would hold up in court if some of those companies would actually go and try to sue Cory Doctorow for defamation. But he essentially is a guy known, like, for discussing enshittification, right? So, like, he says that, companies start by being good to users, but in the end, like, they end up abusing everyone, right? Because they just extract the most value that they can from the product that they have and the users that they have. And he was like, the most important thing, I guess, in the talk is, like, a lot of people, including myself, like, we thought that, okay, yes, of course, we see some suboptimal things happening around us, but we do have protections, right? No. Like, we can have competition in the market, we can have interoperability, we can have, like, labor, so we can move between companies. But Cory actually laid out, like, how all of those protections are currently broken. And, kind of in the end, it would have been a really negative and pessimistic talk if he wasn't, like, essentially just asking people to just, like, resist and, to restore antitrust enforcement, which me being in the European Union, like, we already see this happening. So, yeah. And, to repeal anti-circumvention laws. So, kind of for you to be able to legally reverse engineer stuff that you're buying and to jailbreak a device that you bought yourself.
Yeah, I think that was kind of insightful, actually. I mean, I don't know what this is, if that only applies to the US, but, like, he put this example of, like, the DoorDash app that, like some people reverse engineer to get some JSON that has some data that, like, the couriers actually wanted, like the tip or something.
Yeah, because it's just an API, right?
But, like, apparently that's illegal with the DNCA Act, blah, blah, blah. I don't know how that is in other countries, but that was crazy that, the app is illegal, but the web page is not.
Yeah.
It's kind of weird, right? Like,
because the browser, like, is the browser. Yeah. So yes, like, this is why, kind of some things just move to be application only and they're not available on the web. Yeah, but in the end, like, kind of starting the conference with, like, a guy asking for, like, creation of some international tech resistance. that was an interesting start. So if you haven't seen that talk, like, you decide whether you like it and you agree with what Cory is saying. But it is there on YouTube, and I recommend you actually see it for yourself and see what you think.
All right. Yeah, I really enjoy it a lot. I find it also fascinating that they didn't have any slides, just like the paper and, like, this, turn paper.
Yes.
Yeah, that was
old style, like a guy talking to people.
Yes, yeah. Yes. Well, I have a different talk that I wanted to discuss. I really enjoy Brandt Bucher talk. I always enjoy his talks. They are fantastic. Independently on the content, I'm always amazed by the way he handles Apple Keynote, the software. He has this. Yes, he uses this, like, super cool effect. Like, he has this super minimalistic presentation, exquisite, really high, quality. When he has this minimalistic white background with, like, text, and, like, he uses magic move, which is called the transition. It's this transition that preserves the letter between two slides. So instead of, like, disappear and appear, like, the letters actually move around. And that's kind of cool by itself. I mean, you can use it like this, but, like, he uses it with purpose. You know what I mean? So for instance, and every year is more advanced, and it's, like, really cool. Like, for instance, last year there was this particular usage that I said, like, wow, this is fucking genius. When he said, okay, the talk was about JIT compilers, and this one is also about JIT compiler. The talk is called "What They Don't Tell You About Building a JIT Compiler for CPython." So, but there is this slide that the guy that Brandt had when he wanted to show last year, like, you have, like, a function, and then you compile the function. and then he used the magic move between the C code of the function and the assembly code of the function. And so you could see how the assembly code was formed out of letters from the C code.
Nice.
And it was very cool, very cool.
Yeah.
So this year he did it again, and he kind of like did this animation using the magic move when like I think like he was compiling bytecode to assembly or something like that, and like you could see it like one by one the instructions kind of like transforming themselves into assembly. Very visual. Normally people don't recommend you to do transitions because they are obnoxious, but like, you know, Brandt is really, really exquisite, taste. Very good, very good.
If they hold information, then they're not obnoxious. They actually help you understand.
Right, exactly. Yes, and people are like, visual creatures, but very good. So Brandt talked about like how, like all the weird shit about like the building JIT compilers and whatnot. It was a bit of a status update as well. So Python 3.14 is expected to be like around 8% faster than 3.13. And the JIT compilation pipeline has changed a lot. For instance, the specialized bytecode, like since 3.11, like the interpreter does this thing when like it profiles a bit. I mean, it's not really profile, it just takes traces, but trace information. Yeah, profile maybe is a good term for this. Running code, and basically just creates this bytecode, which now is per thread because it needs to be compatible with free threading, right? Yeah, so now you have one bytecode per thread that is actually accessing the thing. So the idea is that it goes from these mega instructions like load global, like get iter, whatever, to these micro opts that are like broken down mini instructions, and then the JIT can actually compile very nicely to machine code, and then you can reorganize them using the famous copy and patch techniques. So that was cool. And like the talk was about all these like different other challenges that he had to deal with. My favorite one in particular, and we had a good discussion about this, all the memory management. I mean, to be honest, that's not kind of a challenge. Oh man, I really don't want to use the podcast as a platform to just say I was right and Brandt was wrong. So I'm not going to do that. Let's say that he talked about like, I don't know. Okay, I'm going to be a bit pedantic here. So he talked about like how memory management, like they require these things about. So you cannot just call malloc and free, right? You need to map a chunk of memory, and it gives you this like slab of memory, this pure slab of memory, and then you need to mark it executable. Yes. So, and then you need to do this after the fact because you cannot just go and like randomly point to some random piece of memory and then run it, right? Because the OS is going to say no.
Mm-hmm.
So like he talks about this and like how malloc and free don't work and blah blah blah, and this is where I'm going to be slightly annoying. The talk is called "Why They Don't Tell You About Building the JIT Compiler for CPython." I suppose this falls into the description, but man, if you're going to build a JIT compiler and did you find this surprising? It's like, well, no, come on, man, like it's mem mapping. It's like not nuclear physics, but okay, he didn't make it sound like nuclear physics. I'm just being obnoxious. So sorry. I know, Brandt. No, I know you're like fucking Pablo. Like no. I'm fine. I'm just wanted to be slightly annoying for the sake of fun. But yeah, that was interesting, and a lot of people don't know about memmap, and like we discussed this, and you were all the time, right? And I have the best perspective. So but I still find it funny. And who is the podcast? It's my podcast, not your podcast. So I can do this. All right. The other interesting thing that I find very interesting, and he did a very excellent job at describing it because I think it's a very complicated topic, is debugging and profiling. Because this is very hairy, and as he was actually describing it, I was getting cold sweat because like man. Like so the idea is that you have now this machine that turns your bytecode into mega super fucking like compiled code that is fantastic and is super fast. But then someone activates a debugger, and now you need to undo that. But you need to undo that with all the code above you. So that is crazy. So when you start calling stuff, now you're in the middle of nowhere. You're in the middle of one of these memmap chunks from the gods that is executable, and then someone says, I just want a debugger. And then it's boom, and now you're surrounded by these bytes, and then you need to figure it out. That is like quite cool. And the fact that the infrastructure, I mean, once you understand the different infrastructure that they are reusing, or the JIT is reusing, that makes more sense. At the beginning, it sounds more scary than it not, but like it still is very impressive. Like it feels like magic that you can undo that and not make a crash. And the same for profilers, right? Well, I have to say that this is in code profilers. Out of code profilers kind of like work, but they don't need to do anything. And then he touched a bit because I thought, I've been very annoying with this because I think it's very important. Native tools like GDB, Perf, and native profilers that work at the C level. The JIT needs to still work for that. So he didn't have time to cover all of it, but he still did like a very good job of trying to explain a bit, there is some dragons here, but that will require an entire talk because understanding what is the problem is hard. And the other thing that I think it was very interesting as well is like the actually selecting whether you're going to JIT. PyPy people know this very well. You cannot just JIT everything because you're going to blow up memory and it's very slow. So you need to decide whether you're going to compile. So you need to distinguish what is hot code versus cold code, right? What is going to be executed all the time and not changing versus code that is going to be executed all the sometimes or very rarely, or maybe you call a function 6 million times with an integer and then with a float and you don't want to undo that, right? And then when to do it, and if you want to compile it, in line or in isolation and whatnot. So that's the idea, is to have this technology called the tracing JIT. That gets all this information about the code path and it takes the decisions. And that's as important as the actual optimization themselves, right? The fact that you can turn A plus B into assembly instructions for addition is cool, but you also need to know that, that is safe, and now if someone passes you something, what do you do? So,
yeah. And with that, to me, this sort of weird realization was that Python only spends some percentage of its time inside the interpreter, right? And in particular, CPython loves C extensions, right? This is how we've been optimizing things for decades now. So this actually works against the JIT, right? Because you cannot really do much interesting optimizations when you are touching the C extension barrier, because the C API just talks about PyObject star, and you need to pass it a PyObject star, and then a lot of the optimizations that you could otherwise do are sort of impossible to cross. So essentially now the JIT will ask users of Python to sort of work against the common best practice now, which is write a C extension to make stuff faster. Now we're going to ask hey, can you stop maybe writing C extensions?
Right.
Because then we can actually make things 10 times faster, while you cannot make things 10 times faster if you're hitting the C barrier. Now that piece of code will never be JITted.
Indeed. Yeah, that's a very good insight. And the PyPy people really struggle with that particular problem quite a lot.
Right.
All right. So in general, very good. Remember that the JIT is available in 3.13 and in 3.14. You can try it out if you pass enable experimental JIT, and all the binaries built from python.org will have it pre-enabled, not activated, which is different. I know it's confusing. One allows it to be activated and the other activates it. So enable means that you can activate it. Yeah, I know, it's just the way it is. In Linux, you need to compile yourself, so check your distribution. And to enable it, which is the opposite word that I just used for the same term, which is activated. I don't know, man, everything is, these names are bad. So you need to pass an environment variable called Python_JIT, and that actually activates the JIT on the process. But you need to have support compiling by passing the enable experimental JIT.
Right.
And then the idea is that in 3.15 we finally figured out how to properly fix and prove the stack and winding support. We improved the free threading compatibility story, because right now when you activate free thread, it deactivates the JIT, and we make it more than 0% faster.
Very cool. Right. Yeah. Very nice talk.
I like your magic move trick.
All right. I have a talk that touches on a thing that I like, which is three-threaded Python. So there was a talk called Unraveling Community Support for Free-Threaded Python by Lysandros and Nathan Goldbaum. And this was essentially this very fantastic sort of turn of events, where this talk was really sort of proving what Matt Page was talking about during the Language Summit. And essentially it was kind of very concrete in demonstrating how it is not trivial, but it's also not impossible to make very complex systems thread safe, so that free threading can be utilized on this mature software. So first, like they started like by talking about how, we had the GIL for this longest time, and now free-threaded Python removes the GIL, but it doesn't actually mean it's gone forever, because you can re-enable it at runtime if needed. So that's like an important safety hatch that was important during like some of this migration work. And the migration that they were talking about was like this sort of very, I don't know, like maybe not surprisingly, but like impressively well thought through process where first the community started with build systems and binding generators. So like Meson, Conda, Python, and PyO3, like those were targeted first. And once those were done, like NumPy, SciPy, Matplotlib, scikit-learn, Pandas, like those were, made free threading compatible. Whether they're 100% thread safe right now, like we're just going to test and see. But like they are indeed available. Wheels for them are available. You can use them. They scale well already. And only after those two were pieces of community like were made compatible, other packages can now be made for thread safe, because they very often rely on all those other pieces. So Pillow, cryptography, PyYAML, AIO, HTTP, and so on and so on. And they're being made thread safe right now.
Right.
So they discussed some challenges and solutions. And I like this because it was really kind of realistic. It was like, things will happen that you're doing something that just happened to work because of the GIL. Now the reality is not going to be so easy. So they talk about like some most common issues, right? But like, you're using global state. So now you're going to have to move to thread local storage, or use mutexes, which is not great, or atomics, which sometimes you can. And that is essentially sort of like almost free for your performance, since like atomics are like so like cheap as the regular instructions, but much less contention prone than mutexes. So they talk about caches, they talk about mutable data structures that are now like the most sort of complex to deal with, and reference counting. So like borrowed references are the devil. We know this already because we fought this in CPython, but now the community is discovering how they're evil. So like all of this was interesting, but also like tools for debugging, like where it turned out we're not alone, and we also known this already, that we have like thread sanitizer and address sanitizer. Reading what they're saying is not always easy, but it's very rare like that they would actually sort of be useless in what they emit. Like most often, like you're gonna find like, oh, I know what this is showing me. And plenty of the fixes that CPython has seen were fixes that the thread sanitizer or address sanitizer both were showing. Like they were talking about like native debuggers, profilers, and so on. And also like some custom tooling that they wrote themselves for this, like PyTest run parallel. But the most like,
right.
yeah?
No, okay, go ahead.
But the most sort of thing that I personally remember from the talk is something that we already known was a good advice, but now it makes even more sense. Use binding generators like Python or PyO3 or PyBind 11. Don't write it by hand. Like it's much more expensive for you, but it's also much trickier for you to get it right.
Man, people continuously underestimate how hard it is to get it right by hand. Like in the sense that even core developers, right? Because they say, the patterns almost by heart, right? When you have 3 objects, then you need to deallocate 2, and then 3, and then 2, and then 2, 1, and but man, when you have 5 objects, and then you have like 6 error conditions and different things, and one actually deallocates the thing, and now you don't want to reuse the thing, like that is insane. That is insane, and is mostly wrong. And I will tell you as well that most of probably a single-digit percentage of our error paths are grown because of this. So because we never test run out of memory. Well, that is never exercised in the test suite, right? So who knows if we are actually decrementing references there. So yes, like binding generators and getting this right by free, Very good.
Yeah. So that was good. And then like essentially like some of the things that they said was release early with some basic support for free threading and just see what users tell you. Focus on what the most users need first. Just don't be scared to like be 100% ready before you release. Just like show people something, and then kind of they'll tell you like how well or not it works for them. They did also give us some homework for CPython, like essentially asking for like more thread safe data structure primitives, that we could essentially give to the community, to programmers to just safely use. So
Right.
yeah, like that's something that we're gonna have to think about for 3.15 and later. And yeah, like for them, they wanted also some like better coordination between like library spawning thread pools, that like it doesn't end up with everybody doing their own thread pool for everything, because now like you're gonna start something larger and you're gonna have 500 threads. You're not having 500 cores, right? So at some point, the scaling is going to be hindered by just you being too aggressive in the scaling. So yeah, all in all, an excellent talk. I recommend you see it.
Yeah, I really like it as well. It was very honest, because like it's true that I mean, I don't want to say it as a negative thing, but there are a lot of people that when they talk about like free thread, they're overly optimistic. Like, oh, this is the best thing, and like there's no problems, and it's just a bunch of threads. Man, like threads are evil. Like it's just very hard, and like when you have one of these bugs, it's really, really hard to catch, and it's very annoying. So the talk really covered the reality of these migrations, right? Like okay, so you can get it right, and if you're a Spartan about it and you use the tools, it's an order of magnitude easier than not using it, or 2 orders of magnitude. But like still, it's like you now need to reach into the big like, man, if you debug by printf, you're screwed.
Yeah.
Like like so now you need big boy debuggers and whatnot.
Just the existence of printf might change ordering of things.
Exactly. Well, I mean the debugger as well, but like like it's tough, and like I don't even think they mention RR.
I don't recall.
Very good. I really like Lysandros as well. Presents very well. All right. Also, so there are so many talks that I watched that were really good. We unfortunately don't have time to cover them all, even if we talk our usual amount, which is a lot. But one that I actually enjoyed myself a lot, and I recommended a couple of times, because I think it was not only the slides were gorgeous, but like I really liked the message, and it was very nice, is the importance of play by Lynn Root. It was a keynote. And it was a talk about this idea. Well, I mean, there were many ideas, but it was this idea of like playful, like allow yourself like the time to play and like to explore, and like they have this kind of joy.
Yeah.
I mean, the talk goes into more detail, and I don't want to take from it, so I recommend everybody to watch it. And Lynn does such a. I think she draw all the.
Yes, it was hand drawn illustrations, which were like
they were
really
gorgeous.
nice.
Really nice vibe. This is the man when I design my own slides, I always like, my goal is that they feel cohesive. Like it's not just like I just paste together a bunch of stuff.
Yeah.
And like these slides are literally the kind of like idealistic goal that I will have for mine. Like how like, very simple,
Nice.
just drawings. But I don't know, very cool talk.
Yeah, like one I did like, which we will not be able to cover with much detail, but you should also see it, was about PyXL, which is a chip that runs Python at turbo speeds, which essentially is like, which Python? Well, MicroPython. But, kind of the realization is that even your assembly code, right? So that the things that are running on the CPU in the end, all of this is interpreting, right? Like, of course, like now, like modern CPUs with long pipelines, they're essentially also just making all your instructions into tiny sub instructions, and just optimizing those, and so on and so on. But in the end, like we have interpreters all the way down. So like Ron Livney talked about like a design for a chip that is made closer to what the Python interpreter needs.
Right.
And that actually ends up being like, I don't recall the number, like how many X, but like many X faster for MicroPython than running just like regular ones, including like that allows this sort of like thing to compete with like MacBook Air M1, like MacBook Air speeds. So like it's pretty amazing. So I recommend you see that. That was fun.
All right. But we also have some talks though from our own.
Yep.
What do you think?
Yes, let's move on to like our own stuff.
Yes, this is our podcast. Enough of other people's stuff. Now is our own stuff. let's cover it for 1 minute extra than this section. So this took us 40 minutes. I don't know how much in actual final time. So let's cover it for 41 minutes because this is our podcast.
I think we can also go like pretty quickly with this, since like I had one talk and one tutorial, none of which were actually about CPython, so they barely fit this particular podcast. But since, as you said, it's our podcast, like I can just tell you like very briefly the tutorial. Like if you missed it, you missed it because it was not recorded. But it was about how PyScript allows us to explore WebGL without writing JavaScript these days. It was a deep dive into this one topic, like how to use like WebGL within PyScript, like to harness the graphical power of the web browser using Three.js actually. So like we were FFIing, right? Like we were calling Three.js functions. We were creating Three.js objects, since Three.js is a wonderful library that allows you to like, create very complex 3D scenes, and it implements like rendering like, Pixar and, modern Hollywood sort of studios. Obviously, your browser will probably not be able to like handle such complex scenes. When I visited Disney, it was like, one frame is generating for like a minute or something. So, like obviously, if you want to have 60 FPS in your browser, the scenes are going to be less impressive. But you can very impressively create things in your browser, and they can be in Python, and then you can give somebody a link and they can open the thing even on their phone, and it works, which I find is pretty cool. So for 3.5 hours, I had 30 people with me, and we were going through like scenes, cameras, lights, objects, so like geometries, materials, and meshes, just to see like how all of this connects. There was like a series of like 10-ish examples that we went through, and I thought people were actually kind of keeping with me pretty well. I was a little concerned, like, is it going to be enough content, or maybe I'm going to overshoot it by an hour and then everybody's going to be like, hey, where's the rest of the tutorial? But like, no, we were like almost bang on time, so I was pretty happy with that.
Nice.
We ended with like some like basics of the animation system that you have.
How many people do you have?
30-ish. So like there was a bit more at the start, and there was a little fewer at the end. So yes, 2 or 3 people left and never returned.
Not bad. That's not a bad ratio.
Yeah, like, but we were using PyScript in the browser the entire time, so that actually made it much easier for us to set up, since we didn't have to like, kind of fight with like, I have Linux, I have Windows, I have this thing. Only one person had an issue where her Chrome would just not initialize WebGL context, and I had no idea why, since it was a new Mac, so it should just work just fine. But like, she was like smart enough to just be like, okay, then we're just gonna take your like offline bundle and just run it in PyCharm, and it just worked within the browser inside PyCharm. So like she could still like do her thing like just fine. So in the end, that was very impressive. That was the only technical issue that I had.
Nice.
That was my tutorial. Like, PyScript worked also very well. Like there were a few hiccups like that I caused myself by just not noticing a bug that I made, but either I could find it myself or people in the audience helped me find it. So like in the end, that was a pretty fun experience, and I hope people will get inspired to, actually try more of 3D graphics with Python, which is not maybe the most sort of popular usage for the language, but I feel like it should be.
Yeah, I think this has to take off like more this like now, especially for this kind of purpose, like which is not only doing WebGL and whatnot, but also for teaching on these kind of tutorials when it doesn't matter. Like that's such an advantage compared to like having to set up the stupid environment and whatnot. And it's an environment that is very reproducible. I don't know. I wish more people were leaning into this for this purpose. I think
have a meeting with Anaconda like later this week about all of this, and kind of they're almost there, but they're not exactly there yet. And you know why not? Because the sort of ease of setup is there already. The technology is already proven, since like PyScript is what we're talking about, since they have PyScript.com. So you literally have an editor in your browser. You don't have to set up anything. Like all of this is ready there for you. That's pretty good. That is based on Pyodite, right? Like which Hood and Michael Drotboom like before him kind of develop. And this is sort of proven technology as well.
Right.
But what is not really great right now is the debugging experience, which is very dear to your heart, and I get it why, and I agree with you entirely. And currently, when something does not work, every now and again, there's not going to be any indication that something crashed. It just simply doesn't do what you want, and there is no message anywhere. Sometimes you're gonna see a nice box with a message of this is a Python exception, right in your HTML, in your output. That's good. But sometimes it's only gonna be in your JavaScript console, even if it's a Python exception. So just a few places for you to look. The debugger of the JavaScript console does not work for PyScript, since it's debugging on a different level.
Right.
You can use it to debug Pyodite, but not to debug your Python code. But PDB doesn't really work very well yet. So all of those things are this is sort of right on the right side of barely usable right now, which is already very kind of very inspiring to actually make it better. Guido during Language Summit, he had this sort of lightning talk at the very end, saying you know what, when
worse is better, or how it was?
Worse is better. Yes, it was when we started Python, there was a much lower barrier of entry. You could just, start doing things and people would help you actually shape them, because there was no risk of if I just try things out, I'm going to break billion-dollar companies right now and screw with science and, and Mars missions and whatever. So he was talking about worse is better. And now PyScript feels like that, right? It's sort of definitely inspiring to me, definitely interesting, but it's still very early on. So before I would actually say I recommend it to entire classrooms should just go ahead and use it. They need to make the debugging experience more like vanilla, such that all of the improvements.
Or have PyRepl.
PyRepl, by the way, also does not work currently in the browser. You know why? It's a very stupid reason.
Yeah. Well,
Because we forgot. We made it not work, because there is 2 calls to curses that we're making. 2.
Really? I thought we removed curses from the mix.
We wanted to remove curses and we never did. We forgot. We forgot to remove curses.
There's 2 calls. Really? Because it works on Windows. But Windows, right? But Windows doesn't.
Windows has its own patched up curses thing, but you know how it works? It does some C types magic, and you know what you don't have in the browser? _ C types. And that's why, you cannot use the Windows thing, with the Windows workaround.
Well, we can remove courses, and I think we need to remove also not remove, but emulate some of the console, terminal configuration thing, this is CTL.
I don't think we need to do much there. There's already xterm.js, which allows for a lot of very complicated things as a terminal emulator, and mscripten already emulates a ton of stuff to behave
then it's just it's certainly not just the courses thing. Really? It's just that would be embarrassing.
I think it is, because IPython doesn't work.
No. We will check in the next episode. Bets. It's time for bets. What do you think? I mean, you are going to have this big important meeting or something.
It's just that because IPython does work.
You bet that it's going to be that? No, I bet that it's not going to be that. Okay.
All right, let's try.
Now is your time to gather the info.
All right.
You know the price.
I'll do that.
You know the price.
But in the meantime, you should talk about your own talk.
Man, you have this quote here in the doc, and who said this?
A guy at the conference, and I specifically put it down to just share this. Kind of told me this, that Pablo's and Yuri's talk was this. Despite the theatrics, the talk delivered substantial technical content about async debugging.
Despite the theatrics, like in spite of the theatrics. All right, yeah. That was a very fun talk. We practiced like hell, man. Like we have practiced so many times. So this talk was about the work that we have done all together, like Yuri, you and me.
Yeah.
About this asyncio introspection. So it's like several things, not only the in-process APIs, also like the external debugging. And man, I don't know. I know it's our thing and whatnot, and you know, like you're not supposed to talk a lot about this, but like, you know, this is our podcast, and people are already pointing it out that we just do it because we cannot not do it. So anyway, it was such a fun talk, and I think it was nice because the story of how we arrived there it was really fun as well, and it was a lot of work. Remember that it's almost a year, right? Like since not a year, but like from the core developer sprint to now. Maybe almost, right? Like maybe 3 months.
Yeah, like 9 months. Right. Yeah.
So and it was really hardcore work. The biggest PR ever on CPYTHON. Like, you know, to review 16 approvals. Like, you know, really really hard. And like we midway we discovered that our grand vision was like quite bad, and like we had to add more stuff onto it. So I don't know, it was awesome. And the reason this is called the banana talk is because the real talk is like something like Zoom enhanced or something like that, asyncio blah 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 blah. But like the interesting story here is that at the core developer sprint in Bellevue, when we were working on this precisely, we were having dinner. It was Judy, me, Emily, Lysandros, Ivona, and I don't know. And then I don't know. I was joking a lot with this like banana thing. Like, you know, I say a lot this is bananas kind of thing. And at some point I said I was joking on my. I was telling Guido about my crazy ideas at work to do my performance evaluation dressed like a banana. Just for no reason, or like met my Bloomberg dressed like a banana, so I'm the last person he actually decides to meet, you know, like, because at Bloomberg I don't know if they do it yet, but like there is this thing that if you are 6 trillion years in the company, you can actually meet my Bloomberg for a one-on-one for like an hour or something. I don't know why is that a thing, but like, I don't even know if it's still a thing, but it used to be, or at least that's what the legend said. And I always thought, oh man, I'm going to do that, but I'm going to dress like a banana. so in the last person, he decides like he's like, we should stop this shit. Like let's not meet people anymore. These fucking employees are going to be the death of me. right. So I said, all right. So I will sacrifice my any race for like the opportunity to do this. The worst thing is that my manager was quite sure that it was a non-zero chance that I will try to actually do it. So I don't know. So I was telling.
So now you will never meet Mike.
Exactly. Or just to make the performance evaluation dress like a banana, and now he needs to explain. Anyway, I totally should do that, man. Like, well, okay, well, whatever. So I was telling this to Guido, and he was like, "Yeah, you should give a talk like a banana or something." And then it's like, interesting. So I look at Yuri and said, okay, I will do it if you do it with me. And then he said yes, and then we deliver. So it was quite fun. We did explain all this like asyncio shenanigans, very fun to do. And we sadly we couldn't have Łukasz on a stage. But he was in spirit. Watch the talk to understand. And then the grand finale, which like it took a bit of work to actually, make it happen, because like apparently was a bit chaotic outside of the stage. But the idea was to have, at the end of the talk, like Łukasz was sitting down without the banana costume, but then at the end of the talk he magically disappears with Guido, and then like he both dressed like a banana, and then Łukasz asks a question which is like, like this is kind of cool, but like what does the creator of asyncio think about this, which is Guido, and then Guido appears and is like, oh, this is bananas, which is what happened.
Which it was, yes.
It was very cool. Apparently it was hard because Guido was lost or something, like we
couldn't find Guido for a long while. Then he appeared, but yes, like we did not have like, you had perfect timing, like you knew when you're finishing your talk since you practice so much, but we with Guido did not know. So like when we were leaving to actually put the suits on, it was not enough time. So like there was a bit of prodding like to get us on stage, but that was not deliberate because we were just frantically trying to put the bananas on ourselves, banana skins on ourselves.
Exactly.
Yeah. In any case, it was fun. I especially enjoyed the part where you made fun of me mostly. I was the butt of the joke for half of the talk.
When we did that. Maybe two, no? Well, one was more concentrated than the other.
Yeah, but kind of definitely it was fair. There were some sorry design choices that I made for some of our implementation. But yeah, like fortunately I have adults in the room with me to fix my heat death of universe algorithms, and we're good.
All right, and then you have a really cool talk. I really enjoyed it, and I was talking with Ivona as well, and she really enjoyed it. And I think it was Judy who said that you had him in the edge of the seat all the time, like like watching it. That was such a cool talk. Do you want to chat about it?
Just briefly, since it is literally not like doesn't have almost anything to do with CPython. The only connection really is that like again I used PyScript, because now like after the tutorial it was like, what can you use all of this shit for, right? Like what can it be used for? So the talk was called Looking at Audio, and we've made some visualizations of like how sound looks like, both in amplitude measurement and in the frequency spectrum. And I sort of used this to, show people what sound actually is, how digital sound doesn't have any stairs in it. So digital audio is just fine. Like, analog is not better. You can sort of shut down your, warming tubes and so on, vacuum tubes.
Right.
But in any case, like, there was some more fundamental examples, like, kind of showing how rhythm turns into pitch when the frequency is high enough, or show that, you have higher harmonics and they exist for most sounds like pulse waves, but don't for sine waves, which are essentially, as the theory tells us, the fundamental building block of everything that you're hearing, even if it does not look like a sine wave at all. So we were doing like serious stuff.
Pedantic Pablo time, but I forgot the. All right. So long without using this. All right. That's kind of like yes, but also no. I mean, it's a fundamental description, but you make it sound like nature chooses this, but that's not true. Like in the sense that you can. Like this is something called orthonormal basis.
Yes.
So, and you have an infinite amount of them. Like sine and cosine are just particularly nice for periodic signals. It's just, but you can choose others. And actually, the basis is not even sine and cosine. That doesn't you cannot reconstruct any periodic signal with sine and cosine. You need sine of x, cosine of x, sine of 2x, cosine of 2x, sine of 3x, cosine of 3x. So you need all the multiples. So it's an infinite basis, and sine and cosine are one of them, but it's not unique. It's very common, and most of the technology that we have, especially in physics as well, have been created around them, and therefore all the technology that the engineers use have been created around them. And like Fourier transform is based with that as the basis, right? Just because it's simpler, but it's not the only one. You can actually reconstruct as like a different transforms that are not anymore called Fourier transforms, but do basically the same. They give you the space of frequency and energy, which is literally the more pure version. Like the Fourier transform is not really frequency, it's energy, right?
Yes.
I mean it's related, but you can decompose any periodic signal with other bases. There is all these other things called, for instance, Chebyshev polynomials and whatnot. For different things, that's pretty bad for periodic signals. But like there are other bases, and so sine, cosine.
5 minutes later.
Elliptic functions, for instance, as a basis as well, I think.
So,
all right, but I take Pablo out.
Sure, correct. However, practically speaking, like FFTs that we're using for most of like display and not just display, for any calculations in the frequency spectrum, like just sort of based on that. A lot of like synthesis is also based on just sines and cosines and so on. So essentially, I agree with you that this is not like the only possible base, but it is one that already kind of gives us a really good way of thinking about how things just compose. And like the timbre that you're actually hearing is in a large extent not only like, oh, what are the waves, but how they change in time. So you can have higher harmonics and how fast they attack and how fast they decay, and how like that changes over all of the higher harmonics compared to the bass frequency, and so on and so on. So this is why, for example, why a saxophone doesn't sound the same as a flute, and so on and so on. So I briefly touch on this. I did not have any time to actually like go like closer to like the spectrograms, since there I could just do an entire talk about those, since like the entire concept of spectrograms I thought I had like pretty nailed down. I knew like about all of those like different windows and how they impact like how you're seeing, like either you're seeing frequencies better or you're seeing time better, and you know you have all of this sort of like compromise that you need to do, and then there's different sort of ways of scaling, logarithmic or not, like to make it more useful in music. But very recently I discovered like constant Q, and like you know those sorts of spectrograms are like fascinating. They are so much more like informational for musicians. Like they're amazing. I'm.
Are you using them these days, or is just like you find it cool?
I thought like I just randomly like stumbled upon them, but like no software that I know of actually shows them, which is very weird because they just are so much better for music. I don't know why, but in any case, that is super off topic for this particular podcast. So let me just say, like we did some serious stuff, and we also did some silly stuff like drawing images in spectrograms, which all of the examples that I showed, like we're working in a browser, and even in this particular example, you just like had a file selector in a browser app. You put there an image. I specifically don't say uploaded, since you're not uploading to any server. There is no server. All of this is happening in the browser, and then it's just converting it to a WAV file that you can then download from your own computer. But those are simply like the things that you have in the browser. But yeah, like then you can display it in some waveform editor and see, for example, a Python logo that I showed. But in the end, like I showed, like, you know, you don't only do like display with this, you can react to sound in real time using all this frequency kind of information. And what we showed was essentially just to have like a visualization to music that reacted to the sound as it was happening, as it was playing. So, you know, kind of this sort of like a little talk of like more like applications of Python. But it was very kind of fulfilling to me to be able to like connect those two things together, Python and music, which is very dear to my heart. When I wasn't working on Python directly, I was doing a lot of like Python talks, since that was my hobby then. But now that I am working on Python, I find that like I want to talk about also other things, since I talk about Python day in, day out at work all the time, you know. So it was good that I got the opportunity to just do this sort of like off the wall talk. Yeah, like some people came. I didn't have a full room, but it wasn't all empty either. The talk is on YouTube, so you can watch it and decide if you like it or not. I liked working on it, so that I can tell. But you had a talk that was much more connected.
Yes. But before
Python.
that, I'm going to break your mind. I'm going to make your mind explode. You should research a bit what are Walsh functions. Walsh functions. I will write Walsh later how to.
All right. Okay.
Try it.
Will do.
Because you were wrong as well. I mean, it's the same wrong that I explained, but one of the things that you said in particular is like, you know, you saw how you could decompose a square wave with sine wave, and you know.
5 minutes later.
You can decompose a sine wave in a square wave. Wow.
Oh.
Crazy shit. Yeah, it's all about perspective. All right. Yes, I had a different talk. And it was crazy because like the organizer put my the other talk after my banana talk, so I had to run. I had to run like the wind. And Ivona was nervous. I mean, she didn't say, but like she was waiting for me, and she actually couldn't see couldn't watch the end of the banana talk, I think. because he was waiting in the green room as the organizers asked for, because someone is supposed to go with you to the other talk. Which, by the way, our banana talk didn't have a runner that goes with you to the talk for some reason. I don't know. I mean, we are seasoned, so it doesn't matter. But anyway, I had to run crazy to the other place, but we did it. We are right there. And we talk about remote debugging, which is like PEP 768. And then I did, as I mentioned many times, I think, the talk together with Ivona. And she did an excellent job. Really good job. It was her first talk at any conference whatsoever, and the first talk at PyCon as well, in front of a full room, I think, or mostly full.
Yes.
So very, very impressive, very impressive. She did an excellent job. She practiced like hell. I'm very impressed about how much she actually practiced, and it was such a nice thing because, like, we did a bunch of dry runs, and I pointed out like a bunch of possible improvement, and literally she did all of them. Like it was amazing. So yeah, kudos public, kudos to Ivona. I'm also being told that a lot of people enjoy the talk. I just did the introduction and the ending, so like most of the heavy lifting was her on purpose. I also absorbed the technical challenge with the mic. Funny thing. We spent like 10 minutes trying to get the headset mics, and then they say, well, it doesn't work. And the audio people were like, yeah, no problem. This is going to work. Like, it always works. And then it starts to chop. It's like, okay, genius. All right. Well, I don't know. I know it's not their fault. The audio team is very good as well. But, as a presenter, maybe not the best experience. But anyway, we saw that. We did this like TED Talk speech about like remote debugging.
Yes.
And the work is technical and mysterious. So all right. It was cool to present. It was a really hard project involving copying process from other processes, memory from other processes, and different operative systems, and like all sorts of crazy shit. And she explained it really well. So fantastic. I really enjoy my own talk. Watching it from the other side.
No, like being in the audience, it was excellent. And I could only say that like my first public talk was a disaster. So like, Ivona, fantastic. Like, it was...
Kudos. Yes. Fantastic. Well, anyway, let's stop like talking about ourselves. People will get used to it then. We did also a sprint. Let's talk about ourselves in a different way. So we also did some sprints. we did CPYTHON sprints, right? And this time we had some differences, some changes.
Well, yes. So after PyCon US, there are 4 days of sprints. Next year, this is changing to be 2 days, since most of the people actually leave by day 3, and there's only a small number of super dedicated people by day 4. But yeah, like CPython is a big player during those sprints. However, last year there was some unfortunate situation where a newcomer came early in the morning to the room and had some interaction with somebody. We never learned who that was. And the newcomer didn't feel welcome, didn't feel appreciated. So we did not want the situation to return to happen again. So this year we split the room into the cool people. Just kidding. Into the newcomers, first-timers, and the veterans.
Nice.
So it was explicitly advertised during the conference and before it, with a blog post about like what to expect at sprints, like, what you should actually prepare before coming and so on. So there was a dedicated room that I led, plus a bunch of core developers who just showed up, like, just to help me, which was amazing. It was great to have like veteran developers with me there. So that was very appreciated. And the other room could just focus on like deep kind of development with fewer or no first-time people. I don't actually know. I wasn't in the other room. What I do know was that both rooms ended up really liking this setup, because for the newbie room, like we were more like, kind of hooray, let's do something. And the other room like could actually focus on like the issues that make betas.
Right.
So in the end, like we did have a very productive sprint. I did work with a bunch of people who were entirely first-time contributors, but amazingly, they were not interested in like, hey, maybe I can fix this typo in a docstring or something. Like, no, they were like, hey, I have this async.io issue, or like, oh, I have this thing that only happens with the Indian locale, like where there's a crash in some Windows API. So like very kind of concrete problems that like in the end ended up being like really cool PRs.
Right.
So we merged 233 PRs during the sprints. And amongst the developer in residence, since I have to like beat my own drum a little bit here, just to like, hey, it's not only talks about audio that I'm making during the conference. I merged 37 PRs during the sprints. Serhi did 26, even not being there physically. And Peter did 12, also not being there physically. But like, you know, we managed to like do a lot.
You won.
I did not actually attempt to win, but they combined won by one PR.
There are two people.
Yeah, but just to be clear, like it's not just like, oh, the developers resonance, rah rah rah. Like there were other people who also merged like a ton of things. Like Greg merged 33, Eric Snow 17, Victor 15, Hugo 13, Brandt 11, and Kumar, who was also not physically there with us, like merged 10. And some of them were pretty tricky actually. So yeah, like 69 of the PRs merged at the sprints were opened at the sprints for the main branch. Since like all of those 233 PRs merged, some of them were only reviewed. They were older ones. We just actually got to them during the sprint. And some of them are backports, which often they're not very hard to do. Like there's some automation, but sometimes they're very frustrating to do because there's conflicts.
Yes. Look, man, you're looking at the guy who had to backport the tarfile patch to 3.8 because we still support 3.8 at Bloomberg. I mean, we have 3.13, first company in the planet to have 3.14 day one. Yes, like every release. So don't look at us like old people. We are the new people actually in the blog. Looking at you meta running Python 3.10 or something. But yes, I had to backport the 3.8 because we support some other operating systems that are not that new, and like that's the last version we support there.
We backported all the way to 3.9, even though I was really on the verge like whether to backport it or not.
Let me tell you something. Nothing of that patches applies to 3.8. Nothing. And I had to backport all the tests. All of them. And you know what happens?
Like,
dude, the strict parameter is not even on 3.8. I had to put the strict parameter in 6 million files and like thread it over. And now do you know that there is dead code? So this is what happens, right? Like I was like, oh man, and I was doing this while firefighting other stuff, right? So you know, multitask Pablo. And
we're gonna get to that PR anyway, like later on in the episode. No, like not to 3.8. That's a Bloomberg specific problem, or maybe Red Hat too. Like they also like backported all the way to 2.7, dude.
I'm sorry, it's also Red Hat, but they don't share the patches. I don't know.
Like in any case, the sprints, just to like finish that one topic, like they went pretty well. I was very, very happy like with the group of people that I got. Like first day, like we almost had like a full room, if not full. Like it was like wow, like it was like a ton of people showed up. Like, and obviously like they taper down like as the days go. But like my little group at my table like stayed with me until Thursday. So that was pretty cool. And we did actually produce some good PRs and landed some of those. Like, so I was very happy with this. In the main areas of interest, like of course, like most PRs like from that room was tests and testing infra. And there were like 13 of those. There were 8 PRs to docs. But then there were 6 PRs to the JIT, 6 PRs to sub-interpreters, 5 PRs to PyREPL, and 4 PRs to async.io. So, man, like a very sensible, like worthwhile event that actually made Python better. So congratulations to everybody who came and made a change to Python. Those are all very appreciated. And I think we'll be doing this again next year since that worked out pretty nicely.
All right. Fantastic. So it's time for... But we need to be fast because we're already 1 hour and 15 minutes in.
You already started on my PR of the week, since like I essentially took what Peter was really painstakingly working on for weeks.
Sorry, I didn't
well, like
thought it was
that's
your
good.
PR.
Like it just means it's important. So I took what Peter was working on for weeks, and then I said, I made this.
I made this.
Yes. So what happened was we got some reports about security vulnerabilities in tarfile, and Peter prepared a fix for essentially the entire roster of identified vulnerabilities. In sort of like at this moment of like collaboration between all developers in residence, including the security developer in residence, Seth, we sort of worked together to publicize all of the CVEs, to release Pythons on the day of publication of those CVEs, to essentially like make sure that like people are not being left without support once the vulnerabilities are public. In the end, it turned out that the PR actually needed quite a lot of massaging, because the test that we have for the fix is complex enough that to make it pass on every build bot, not easy. So I did that part. Like Peter did all of the actual fixing, but like I made actually the build was green. In any case, like what is that even doing? Like what is happening? So tarfile used to be pretty sort of lax with security until Python 3.12, because tarfile actually allows you to specify lots of weird behaviors inside the archive, and they're just being unpacked and things happen to your computer. Like you can, create symlinks, hard links, you can move things around. Like it's weird. So in 3.12, actually Peter also like added this where tarfile gained support for filtering, so you could explicitly disable dangerous features for tarfile, or explicitly agree that like this file is safe, we know where it's coming from, so let's allow all the features of tarfile. So that's great. 3.12.
That's the strict thing, no? Strict equals true.
Yeah, no, the filters for the data filter,
filters.
It's like so that was that, and the OS path, real path strict, like that was around the same time, I think, too. But in any case, this couldn't become the default in 3.12, since it would just break people's ability to, unpack archives that they could unpack before. So this only becomes the default in Python 3.14, which we will be releasing in October. So you have not seen this yet, but in Python 3.14, we'll break probably some old archives being unpacked naively because they're doing kind of risky operations. But in any case, in the meantime, it turned out that there were flaws in the filters, so there were ways to circumvent them. And the most powerful way, which caused the most pain with the testing, was that by carefully crafting symlinks in tarfiles in such a way where the links themselves fit within the maximum path length for your platform, but after they are resolved, the path goes over the limit, and through careful preparation of the tar file, you could create hard links to files outside of the destination path. And with a hard link, you can now just write to it, so you can overwrite a file that you were not even unpacking. So you could do like pretty crazy stuff. And because of how tarfile works, you could also create new files in the same directory, in the outside directory.
Jesus.
So essentially with that, like you can create some file that you could just use to open a security hole to then essentially take over a system and so on. So that was a pretty critical vulnerability. Now it's all fixed. Like it was essentially for us working like 12-hour days for 2 days to just push this through. It was not easy. But in the end, we made all releases of all Pythons that are currently supported, well, save for 3.14, since it's not really supported, you shouldn't use it in production. So, like the fix is there, but we didn't release it yet because you're not supposed to actually have it in production. But all of the other Pythons got releases, including 3.13.4, which you should not install. Don't install that shit. It's broken.
Why?
We're going to release a new one. 3.13.4 has, we thought, one regression with how generators work, async generators work, but it turns out that there are more regressions. There's like 3 regressions in 3.13.4 with backwards compatibility that should not happen for 3.13. So 3.13.5, if it's not being released as we're recording this, it'll be released tomorrow. So like it's gonna be an expedited release of 3.13. So if you were just like, hey, I should actually upgrade to 3.13.4, no. Upgrade to 3.13.5 as soon as it's out.
All right.
Oh, but the regressions are not related to the tarfile thing. Like they were just entirely different ones. But like, it's there were just many changes in 3.13.
Yes, I know very much this patch. I had to babysit all of the shit to 3.8, and that I thought that was going to be. I picked the 3.9 backport and said like, okay, this will be smooth sailing. No. All the files collide. All of them. Tests that were not there, tests that use infrastructure that was not there. Man, at some point I look at the thing and it's like, dude, half of these variables are death code. And that is how tarfile is actually. It has a bunch of death code.
Yeah.
So it's like, all right, okay. So I'm not touching that, I suppose. Incredible. Cool. I have a PR of the week.
Yeah.
I actually was very productive since PyCon. So, but I picked the stupidest PR because, I want to send a message. All right. That's PR something. I don't even know the number. It's the last one I did. All right. Do you know the bug?
I don't know.
Let's see if you can know live what was the problem. All right. So I will tell you a secret.
Yeah.
The summary of this bug can be summarized as C, consider them harmful. All right.
Oh, we never knew that.
The legal language.
Interesting. Okay, so this is the bug, Łukasz Lanka. So you know that I added a bunch of like cool syntax error messages, right?
Yeah.
One of the most popular one is the you forgot a comma one, right?
Yep.
All right. So that happens when you do, for instance, parentheses, X space, Y, close parentheses, and then it's like, oh, maybe you forgot a comma because maybe this was a typo. All right. Okay. That was cool. But then we discovered that is kind of like not enough because like there is these keywords, I don't know if you know about them, it's called soft keywords. There is this thing called soft keywords, quoting Victor Steiner. There is this thing called CPI. So there is this thing called these soft keywords.
Like
and it turns out that backtracking there is very tricky because how the parser works, and I don't have time to explain because it's quite tricky to explain, but like you can imagine where the problem is more or less because you are parsing incorrect code, right? Remember, you're parsing incorrect code.
Yes.
So you have match space X, right? And then there is incorrect code that follows. It's going to try to parse it as a match statement, and then it's going to backtrack and try to parse it as not the match statement. And then it's going to tell you that maybe you forgot a comma between match and X. Oh, which is not good, right? You don't want that. So there is a secret thing, and it happens when there is soft keywords, to be honest, but there is a secret thing that checks if the left side or the right side are soft keywords. And if that is the case, then it doesn't show the error message. That is good.
Okay, yeah.
All right. So that was what we thought it was happening. But then we received this bug that says, okay, if you do match X, then you don't get the error message, right? That's expected. But also, if you do, for instance, XY, you get the error message. If you do Łukasz space Langa, you also get the error message. But if you do mat without the actual end letter, then you don't get the error message. If you do mat, you also don't get the error message. If you do m, you also don't get the error message. And if you do m, you also don't get the error message.
Okay.
What is the problem? Without knowing anything about anything, what do you think is the problem?
Well, I mean, like if it already sort of like matches like with match, but it can be a substring of match, then like you're doing string comparison wrong, but I don't know how. Like,
what is the function to do string comparison in C?
Well, like the one that you shouldn't be using is like this what?
Yeah,
like
it's
CMP, but like you should use the one like that has the N in it, so that like
No, it's the one that has the size.
yes.
Well, the end is the same, no?
Yeah, like yes. So like you use this one and that should work. But like I think we have like literally
That
like
is the
linters,
problem. That is the problem. You see, we are using the safe one, but we are passing the how much to compare, and then we are using as the size of the left side of the comparison, which is the token. So we say yes, please compare the input of the user, which is mut or with the keyword, but only the first n characters when n is the size of the keyword. So when the keyword, when the user says, "What about m?" Then we say, "Well, are these two letters the same as the keyword match?" Yes. Okay, then it's a soft keyword. I mean, it's only for the error. The actual parsing is different, but yes. Wow. So now there is a check for the size first and whatnot. So yeah, like. Mistakey. I like it because it was, but and also we got like I don't know about this. Someone tried to solve this, but I'm mostly sure it was AI generated because like man, what a weird PR. I mean, I don't want to be rude if this was an actual PR. I really don't think it was an actual PR done by a human, or at least maybe it was a human using Mega AI. But like it was very AI like because the PR was like literally not doing anything. It was just like in the generator changing some random stuff for functions that don't exist. So it was like really wrong, like uber wrong. And then the text of the PR, the summary of the PR was like changes made, streamline functions for the parser. It's like, that's kind of weird. Yeah. And like a lot of people were even reviewing the PR, like, test, change these functions. Like, how is this even supposed to work? Obviously no tests and whatnot, right? But so I had to close that because like, I mean, that was so far from actually doing anything that like we couldn't be savage. But I fixed it by obviously addressing the real reason, which is that C is dangerous.
Using the safe thing was unsafe.
Using the safe thing was unsafe. Correct.
Nice.
Well, I mean, using the unsafe thing will have been unsafe because if you compare me with match and then you compare all the things, you're going to compare too many things.
Yeah. See, like M and random bytes.
That's it. Yeah. Depending on what you put on the left. Yes. That was my PR that I want to bring up, but I'm not going to talk about this in this session because this is already long. But my most, like the PR I'm more proud about, which you know about, is the 1 million PR. And our listeners will be saying, what does it mean? You will need to wait until the next episode. But it will be glorious.
Yeah.
It will be glorious.
Yes.
Glorious. Both the episode and the actual feature. Exquisite.
Yes. It's audio rate.
Exquisite.
It's audio rate.
Yes, you will see. 1 million. And it's not even about Mark Shannon this time.
What's
going on
in CPython?
We actually don't have much time to talk about what's happening in CPython, but I still selected just a few things at least that we can just like shout out to because it would just feel super unfair to not have the section at all. But it is barely there, so sorry for everybody who we missed this time.
Well, the first thing that I want to highlight here is PR 133365. Very, very popular number. Right, yes. So this is for implementing PEP 784. This is Emma that implemented adding the CSTD compression to the new compression standard library.
Standard.
Standard. I wonder what company did that. Łukasz maybe is paying you or something. Is that true?
No, is that true? Paid by the Python Software Foundation already.
Yeah. Is that Python Software Foundation a shell company? Like, is that just moving money around? All right. Okay.
It's a good compression algorithm. Come on.
Exactly.
And also, Emma is not working for Meta. So.
Well, it's working for another big company. Maybe it's a conspiracy or something.
Of big companies. So you need to ask Cory. Or you need to ask Cory Doctorow about this.
Well, anyway, C standard, or like the English people would say, Z standard. Well, not about Z standard.
Z standard.
Z standard.
Yeah, Z's dead, baby.
All right. Okay, CSTD. Sounds like an STD. Okay, well, whatever.
You want to talk about this more?
No, it's just very cool. Like it was time.
It is very cool.
Yes.
And then also like you look
job.
at this PR and those hundreds of comments on it, and then you look at the other PR, which is the documentation for it, and the hundreds of comments on it. This was a ton of
This
work.
monster is a 3,000 line of code monster.
It is big. Plus the documentation is also big because there's a new module like, for like compression. So, amazing.
Yeah. A lot of people were dismissing this because they were like, it's just like in the thing. I'm like, look at the PR, dude. Like, it's just enormous. Yeah, and then there's the CSTD module. I mean, that's not a lot, but like, then there's this is very good stuff.
Yeah.
Very good stuff.
I want to talk about, so we have one new feature and one performance improvement. So I'm going to be talking about this one.
All right, go ahead.
We had a PR to optimize state transfer between concurrent futures and async.io. So if you have concurrent futures future objects, they're not the same as async.io futures. But sometimes you actually have to convert one to the other. So you would think like, that's weird. Why would you do that? Well, it is actually very common if you are using executors in async.io. So now the GitHub user B Draco did make them 4.4 times faster, which is like one of those things where like, okay, if we are already talking about multiple X times faster, I'm always for it. Like I always like to see this. So
Very
if you
impressive.
have a ton of executors in free threading, you're going to be using thread executors more. And currently, if you're not there yet, you're going to use process pool executors. You're just going to do this concurrent futures to async.io transfer pretty often for smaller tasks especially. So 4.4 times faster for this is actually noticeable in real world applications.
Very nice.
A very, very sweet performance improvement by B Draco.
Exquisite. And then we have another interesting PR by our friend Kumar, basically working on C-types, making PyCfunc pointer call lock-free, which is a very common one in C-types. You're doing evil stuff, but that's how you call C functions. And this is important to improve the performance in free-threaded build because a lot of people use it, and then it's important. I think we use it a lot in PyRepo, the Windows one.
Quite possibly, yes.
Yes.
Yeah. And also, that's essentially also making the performance of this like, twice as good. So good. I think that was actually like a regression that we had like from Python 3.13. So we're not going to be magically much faster in 3.14, but that does mean like we caught in time a regression that would make people upset. So Kumar, excellent job on this. And now, I do have a bunch of weird shit because I decided,
weird shit. Let's go.
Yeah,
Let's
because
go.
we always have like those like very serious changes, like free threading makes things thread safe, performance optimizations make things performance optimized. But like every now and again, people make changes, and you look at the change, you're like, what the hell? So one of those is to remove a long deprecated Java_var function from the platform module. So I was just looking like, why do we have this? So yeah, like apparently there were times like a long time ago when Python was closer with CPython, we had like this command line option just reserved for them for no reason. Like it was never actually used for anything. So now it's actually free too. But this particular thing actually, it turned out, necessitated like quite a few few files to remove, since all the documentation and everything. We need to now say there is no way to get the version interface for Python anymore from our own platform module. So if you can see, like all of this looks very Java-like. If you look at the PR, like there was just a bunch of Java get props to just get like information that nobody will ever ask about from CPython. So this is gone. This was the first like very weird thing that I did not even know, honestly, that we still have this in the platform module.
This is weird.
Yeah. Another one was we also had CGI support in HTTP.server. So this is also now removed. So there is no CGI HTTP request handler anymore.
Yeah, that's weird, man.
-- CGI flag is gone. So if you were dependent on that Well, too bad, man. Like, there's no CGI support anymore in the production unready HTTP.server. You shouldn't be using that anyway,
Right.
but especially not for CGI. So this is gone. And another one that I was also like weirded by seeing it just in the list of recent PRs landed was PR 30,000, so 30135. That looks like a really low number. So I clicked on that and I'm like, what is going on? And there is like a really nice PR to actually allow 3D printing dict and mapping views. So if you have like dot keys that you are calling on a dictionary or dot values, those things would never pretty print in Python before, which is like a big omission. Like, why not? Well, we never added this. But we actually had a contributor, Dev Danzin, create a PR for this back in 2021.
Jesus.
And yes, and it just stayed there unreviewed for this long time, all of this time, until Greg noticed it and landed it, 3 weeks ago. So yes, like
Very nice, very nice.
it's worth keeping even old PRs around sometimes.
There is
since-
always hope. There is
yes,
always
there
hope.
is always hope. And now, like,
If Greg is around.
it is sort of sad that like 3 weeks ago, that means like this already missed beta. So this is only going to be available in pretty print in 3.15 next October.
No.
Yeah, because it's a feature. Well, you know, but in the end, good that we actually had this. So, you know,
Well,
we're only people in the end, you know. But yes, 4 years it took, but it's merged now.
all right. I think we're done. Only 1 hour and 36 minutes. Wow, amazing.
Yeah, pretty cool.
I mean, amazing, no? I suppose it's our shortest episode to date.
Oh, this is not even close to our longest episode, and this is not close to our shortest one, which will be unbeatable. That was the live one, 30-minute long one from last PyCon. We will never be as short as then. That's not possible.
Impossible. Well,
Yeah, that's impossible.
one man can dream. But next episode is going to be very cool because we're going to talk about like 1 million. 1 million what?
Oh, so that's your PR of the week, but I also have like a very interesting idea for the topic of the episode. Which
All right,
I
well,
think-
we'll fight. But remember, we did a bet. We need to follow.
Oh, and there's the bet. Mhm.
Yeah, that's the real catch. Like, who will win? Who will be humiliated? Who will be humiliated? We don't know.
Humiliation-driven development.
Whoever wins, whoever wins is going to be very nice. You can also say humiliate, and it will work as well due to the bug in the parser. And
Yes,
All right.
exactly.
All right.
See you next time.
Until next time.